Today we're going to start logic. And logic is a very unique topic because there are no variables, there are no numbers, there's nothing to solve for. We're basically looking at different statements and analyzing them and seeing if they make sense. And the best way to see what this means is to just start. We're going to start off with an example. And in our example, we're going to have two statements. We call our statements propositions. And in this case, my first proposition will be, it is raining. And my second proposition will be, I am wet. And again, these are just examples. So it is raining and I am wet are just examples, but P and Q are often used, these lowercase letters are often used to represent propositions. So I am going to make something called a truth table. And a truth table helps us explore various combinations of these statements. So these statements, we are going to look at everything possible. So we're going to look at if they're both true, if they're both false, if one is true, if one is false, and we're going to explore these things. So in our truth table, we'll have both true. We'll have the first one true, the second one false, the third one false, then true, and finally both false. So this is every combination of whether or not two statements can be true or false. So they both can be true, they both can be false, etc. Now, with that, we can start combining these statements in various ways. And in order to do that, I'll have to introduce you to a few symbols. So we're going to do that on the right side of the page. And the first symbol that I would like to introduce you to is the not symbol. So that means not, and together with the proposition, it means not P. In this case, it means it is not raining, not P. So if I have not P, anytime that P is true, not P will be false, and vice versa. So if it is not raining is true, then if it is raining is true, then it's not raining will be false. So when P is true, not P is false. And when P is false, not P will be true. Again, it's the opposite of P. The next symbol that I would like to introduce you to is the and symbol. So whenever you see that symbol between two propositions, it means P and Q. So in this case, or every case actually, for P and Q to be true, both must be true. For both things to be true, they must be both true, obviously. P and Q, for P and Q to be true, both must be true. So they're both true in the first column. P is true and Q is true, which means that P and Q is true. However, no other case are they both true in this example, so all others are false. P and Q, for P and Q to be true, both must be true. The next symbol that I would like to introduce you to is P or Q. Well, the or symbol. And the or symbol looks like a V. So P or Q. Now, for P or Q to be true, at least one must be true. Either it is raining should be true, or I am wet should be true, or perhaps both can be true. So for P or Q to be true, both must be true. So let's put that down. So for P or Q to be true, at least one must be true. So in the first one, they're both true, so it's true. In the second row, P is true, so at least one is true. In the third row, Q is true, so at least one is still true. But in the final row, they're both false, so P or Q must be false. At least one must be true for it to be true. And the last symbol that I would like to introduce you to now, we have some later, but the last symbol I'd like to introduce you to now is the or but not both symbol, the exclusive disjunction it's called, but you don't have to remember that. You just have to remember that this symbol means or but not both. So if I have P or but not both Q, it's P or Q but not both. Which basically means that one or the other has to be true. One must be true, one must be false in order to be true. So we have here in the first row, they're both true. We have P true and Q true. So, but it's or, but not both. In this case, they're both true, so it does not work. So this one is false. Again, to be true, they have to be different. In the second row, however, P is true and Q is false. That's one or the other, but not both, which works, so that's why that's true. The third row is true as well because one is true and one is false. But finally, the last row is false because they're both false. Again, for or but not both, one must be true and one must be false. So now we can practice this a little bit. And the first two columns are always the same. So first we can fill those out. The first two, true, true, false, false, true, and false, false. So those two columns are always the same. So now we're being asked to construct the following truth tables, and they are using the symbols that we used just now, but they're combined in different ways. And that's on purpose. So in our truth table, we see that there's a bunch of not P's and not Q's, and we're going to have to use them eventually. So let's just first get columns for not P and not Q. Again, not P is the opposite of P, so it's false, false, true, true, the opposite of P. And not Q is the opposite of Q, so it would be false, true, false, true, the opposite of Q. Now the first question asks us to construct P or not Q. P or not Q. So we're going to do that in this column, P or not Q. So that is where we're going to put the answer for 1. In order to do this, we have to focus on two columns. We have to focus on the P column, and we have to focus on the not Q column. And then we have to use the rule that we came up with in the first part of our video, P or not Q. So at least one of those must be true in order for this statement to be true. So P is true, and that's false. Well, P or not Q, one of them, at least one is true, therefore P or not Q is true. P or not Q, so we're looking here, and at least one is true. Actually, they're both true, but that means at least one is definitely true, so then that's true. And we have here false and false, so both of them are false. At least one isn't true. We don't have any of them being true, so this is not true, actually. It is, in fact, false, because at least one is not true. And in our final row, we have a false and a true, and at least one is true, so therefore this is true. And our answer for the first part is true, true, false, true. True, true, false, true. Okay, so now we're ready for the second one. And I got rid of all the clutter from the first one so we can focus on the second one. And here, the second one says not, and then in parentheses, P or Q, but not both. Well, it's not like regular algebra when you're distributing something like a negative sign. That does not work here. So we will get rid of that idea from the get-go. We have to do what's in the parentheses first. So we have to, if we're constructing that truth table, we have to first do P or Q, but not both. And you'll remember from earlier in the video when we did P or Q but not both, one had to be true and one had to be false in order for it to be true. So in the first row, both P and Q are true, which means P or Q but not both has to be false. But in the second row, one is true, one is false, so it's true here. Third row, P is false, Q is true, so it's true here because one is true and one is false. And in the last row, both are false, which means that it's not or but not both. So the first one is false, second one is true, third one true, last one false. Now, because we have that in parentheses, P or Q but not both, and that's negated, well, everything will be the opposite of what we just did. So we're looking at this column, and that's our P or Q but not both, and we're negating it. It's the opposite of P or Q but not both. So we have true because that's false. We have here false because that's true, false because that's true, and true because that's false. And that is our answer to part 2. Now, finally, we can do part 3, which is not P and not Q. Not P and not Q. And since we already have not P right here and not Q right here, we only have to focus on those two columns. If we didn't have it, we would create it so we could focus on those two columns. So not P and not Q. And to be true, both those statements should be true. And again, we're not focusing on P and Q anymore. We're focusing on not P and not Q. So to be true with and, both must be true. In this case, neither are true, which means that is false. Both must be true, but only one is true, so it's still false. Both must be true, but only one is true, so again, still false. Both must be true, and finally we do have a case that both are true, so that's true. And that's the answer to our third part of the question. P, not P, and not Q is false, 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 true.